In today's video, I'm going through exercise 1.36. In this exercise, we need to determine how the electricians wire up switches. Basically, the two-way switches that you might have in your house, where both switches can turn the light on or off. Basically, they toggle them. So the exact text on the question is, although a few electronic circuit designers know how, every electrician can wire up a light fixture so that any number of n switches can turn it on or off. See if you can figure out this generalization of figure 1.112. It requires two SPDT switches and n-2 DPDT switches. So for this question, first of all, I will just briefly explain what different types of switches are and what they mean, especially when we say SPDT and DPDT. And then I will show you how a two-way switch can be drawn up. And then we'll finally go on to do the generalization for this switch, where we can have any number of switches that can toggle a light switch. So first of all, let's look at the SP-ST switch. So what does SP and ST stand for? So the SP is basically single pole and the ST is single throw. So pole is basically your side on the left hand side. I generally call this the input. Obviously you can think of it in different ways on whatever suits you. And then your throw is basically the output, which is this side over here. So you can see on this circuit you have one input and one output, therefore single pole, single throw. So obviously this is one of the simplest switches that we can have, and this switch can be used to basically just toggle on off a connection. Some examples of this might be your reset circuit on a microcontroller. The next type of switch that I'm going to describe is the SPDT. So obviously our single pole stays the same, and now we have DT at the end. DT basically stands for double throw. So similar to before, we have a single input. However, in this case, we now have two outputs from this switch. So as you toggle the switch, you can see that the connection that is coming from here can be here or here. Now these switches can come in two different variations, where you have a switch which connects to this or a second state where it connects to this. These types of switches can also come in a state where you have three different states of the switch. State 1 would be where it connects to here, state 2 would be where it connects to this direction, and state 3 where it connects to none of them. So those kind of switches would be typically denoted as on, off, on switch, whereas the first type of switch that I described would be described as on switch, where there's always a connection made to the output. This type of switch basically allows you to toggle the input between two output points. The third type of switch I'm going to describe today is the DP-DT. So now we've replaced the SP with a DP, so now we have double inputs, so double pole, and for each input we have a double throw. So we have two inputs and four outputs. These two poles here are mechanically tied together generally so that they trigger at the same time. So if you were to press the switch, both of these connections would go to the other state. So this connection would go to this direction and this connection would go to this direction at the same time when there is a link in between. Obviously this switch is very similar to the SP-ST switch. However, you can see that it's just doubled up. So this switch allows you to toggle two inputs between four outputs. Obviously the four outputs are kind of isolated between the two, so each input has access to two outputs. So before diving into the question, let's first look at a two-way switch, which is not the generalized version. So this circuit diagram that's on the screen now is also shown in the Art of Electronics book on figure 1.122. Now you can see in this circuit we have two single pole double throw switches. Obviously this one is flipped over, so we have a single pole here and a single pole here, two double throws which are connected together for the two switches. This is the kind of configuration you might find in a living room or something, where you have two switches that control a single light. And you'll have noticed, the both lights can turn the switch on or off, basically toggle the state of that switch. So let's have a quick look at how this circuit works. So obviously I've built the circuit up and I've got a small LED here, 6 volt supply. None of that is quite important. The only thing that's important is whether the LED is on or off. So I'm going to press simulate on this. So you can see on this simulation circuit that the current is flowing. So right now you see there is a current path going from here, and from this pole it's going to its top throw, and from top throw the other switch, so this is the second switch, it's going back through the LED and onto the ground. You can see the ground of the LED is always connected. Now if I press this switch, you can see that the input voltage is no longer connected to the LED as this has toggled. Now I can press any of the 2 switches here to put the LED back on. So if I click this switch over here, obviously then I will have a circuit path through this connection. If I click this switch over here, then I'll have the connection path through here. So now moving on to the question itself, the question is telling us that the solution will need 2 SPDT switches as we have over here, and N-2 DPDT switches. DPDT switches are basically 2 of these, as I showed you in one of the slides. So as a starting point, I think those N-2 DPDT switches will go in between these 2 switches over here, and I believe these 2 switches will be on the side. So what I'm going to do now is draw this circuit and move these components over. I'm going to break these tracks, and then I don't have DPDT switches on this simulation circuit. However, what I can do is use 2 of these and basically pretend that they're acting as one. So let me put this in the simulation over here. So what we need to be able to do is toggle any one of the 3 switches on here. You can see that we have N-2 DPDT switches, N being 3 switches, -2, so 1 DPDT switch and 2 SPDT switches. So this meets the requirements that have been defined in the question. We need a way of connecting this where any one of these 3 switches can turn on or turn off the LED. So the first thing I'm going to do is connect up this point over here to here. As you can see, there's 2 inputs and 2 outputs from this switch over here. Obviously we have 2 connection points over here as well, so there'll need to be 2 connections coming over. So I'm going to do this by trial and error. So let me try and connect this up and see how well it works.
A few hours later.
think I've got to a solution which we can use. So I finally found a software solution that works for us, and I can show the results from what I've basically found through mainly trial and error. The only deduction I made was the two SPDT switches on the outside. Basically, we can look at this internal block as a changing amount, so we can continue repeating this block for as many times as we want, and the circuit should still continue to work as we are seeing it now. So how this works, basically, I can toggle any switch to turn the LED off. So let's start with this. But I thought my solution wasn't working properly. I tried a few different things, but I think what the problem is, just looking at this solution in more detail and going through the steps of looking where the current flow is, I think the simulation software is not the best in terms of simulating a DP-DT switch. So you can see over here, obviously we had a connection from here to here. Now, if you look at the battery, you have power supply going from here through this SPDT switch, through this DP-DT switch, and through this connection over here. So the LED in this case should be on. Obviously it's not shown as being on, whereas in this case it does show it on as well, but for some reason it doesn't like this connection over here. I'm not entirely sure why that is, but you can see that there should be a connection through this path here. So we can use basically any switch to toggle the LED on or off, so in any sequence as well. So let's say we want to, so right now this LED is on because we have a path through this connection here. Now if you toggle the switch, obviously we've broken that connection, so the battery is no longer connected to the LED. If we press this switch, then the LED comes on. If we press this switch, the LED goes off because there's no longer a path. If we press this switch again, the LED comes on. If we press this switch, the LED comes on. If we press this switch, the LED goes off. And if we press this switch, the LED comes on again. So you can see we've got a three-way switch using two SPDT switches and one DP-DT switch, which is N-2, so N being 3 switches in this case. With 4 switches, we would basically just repeat this architecture as we have 2 inputs and 2 outputs. And I believe this would be the solution for multiple, or a generalized solution where we have 2 SPDT switches. So obviously this connections would go down to here, and these 2 connections would go to this switch here, and then we would be able to toggle any of this switch to basically toggle the LED on or off. Thank you for watching today, and if you have any questions, please let me know in the comment section below.